Hi, everyone. My name's Luca. I'm a data scientist here at Snow Labs. And today I'm just going to be going over two tasks, token and text classification, using two different BERT-based models called BERT for token classification and BERT for sequence classification. So in terms of the outline for today, I'll first introduce those two tasks, so token and text classification. We'll then go over those BERT-based models and how they work. I'll walk you through some of the ways we integrate these models into Spark NLP. And um, after that, we'll just go over some Colab notebooks that are publicly available for you to run these models and try them out. So just introducing the tasks that we're talking about today. Token classification here is a task, also known as named entity recognition or NER, where you're essentially detecting, you're feeding in a sequence of words or a sentence and trying to detect single words or groups of words, which are called tokens, and trying to detect relevant ones or ones that are relevant to your use case. So in this case, in this example here, we have a sentence, for example, that could be from a historical document. And within that sentence, the idea is to detect words or groups of words that uh, that are related to people. So this we get a person tag here on Mark Zuckerberg, or organizations. So Facebook here gets a organization tag. So within the sentence, each token gets a tag assigned to it. So in this case, as I said, Mark Zuckerberg is a person, launched doesn't get any token. Facebook gets the organization tag. And on February 4th, 2004, this is also no tag. So that's for token classification. For text classification, we basically are attempting to classify a full sentence or a document. And over here, you can see this text classification task is to classify whether a message is a spam or not a spam. In this case, just by reading quickly through the text, you can see that this is definitely a spam message and it's actually correctly been classified as a spam. So these are the two tasks of interest today. And I'll just go over ways to do these tasks using BERT-based models. So let me introduce these models. So BERT is a paper that was submitted to arXiv in 2018 by some Jacob Devlin and colleagues at Google. Um, and BERT stands for bidirectional encoder representations from transformers. In essence, it's a language model that has multi-layer bidirectional transformer architecture, which are just stacked encoder blocks. The breakthrough here was that at the time, the other large language model in action was, which was OpenAI's GPT, was this language model was not capable of looking at context bidirectionally. So each token would only be able to look to the left of itself. Whereas, and so what BERT introduced was the ability to be able to attend to tokens on both the left and the right side of each token. And so it turns out that this functionality allowed pre-trained models to, pre-trained BERT models to perform quite well at a wide range of tasks with just an additional, in general, just an additional output layer and no substantial architecture modifications. And among these tasks that it turned out to be good at were token and text classification, which we just covered. And so we're going to try and understand how what those minor architecture modifications are in order to carry out those tasks. So let's start with token classification. Let's say that we have an input sentence, and our goal is to predict for each token which label should be assigned. So over here we have an O, which stands for no label. So this would mean that this first token doesn't get a label, well, it gets an O label. And the second token here gets a person label, which means that this token corresponds to the name of a person, and so on and so forth. So the way the base language model was restructured here is quite simple. It's just for this task, it's just by slapping a linear layer on top of these hidden state outputs, we're able to classify each token and just assign it a class. And the fact that it's able to look bidirectionally at each token makes it quite strong at this task. In the case of text classification, we have again a sequence of tokens, that's fed the same way through um, this model, and we have we have this special CLS token that's added at the start of the sequence. CLS stands for classification. It's a classification token, and what happens is that you can just then slap a linear layer right on top here to classify the sequence of texts. So this is what allows you, for example, to predict whether text is spam or not spam in the case that we saw. And so so this is just a basic overview of how they work or background. And using these models in Spark NLP is quite simple. But so before I go into that, just to introduce Spark NLP to those who don't know the library quite yet. Spark NLP is a very popular open source NLP library that's built on top of Apache Spark, which gives it the very unique ability to scale on clusters and process huge amounts of documents. And this, among many other things, makes it currently the most used library in the enterprise sector. The library is actively maintained by Johnson Labs, and it has close to 2 million downloads per month. It's at like 1.7, 1.8 right now, I believe. And as part of the library, there are over 6,000 pre-trained models available and over 250 languages. And as you can see, these include transformers like BERT, which which are of interest today. So to understand how these models, BERT for token classification and BERT for sequence classification are used in Spark NLP, we'll have to go through some, the way that the library is used. And over here you can see, so this is the core component of the library. Is you have these components which are assembled into a Spark pipeline. So the first core component, this is always the first step in Spark NLP pipelines. It's the document assembler, which takes in as input a text column, which contains whatever text you're looking to run your token classifier on. And this assembles it and feeds it to the tokenizer, which then tokenizes your text. And the output of these two components is then fed into this BERT for token classification pre-trained model. Over here, we're using the BERT-based token classifier, which was trained on the Cornell 2003 dataset, which is meant to detect like the basic NER classes like person, locations, organizations, and there's a miscellaneous tag as well. And so as you can see here, it takes in the token and the document columns. Sorry, so from these two outputs. and it outputs a NER column. Well, we've assigned it an NER column name output. We set case sensitive to true since BERT is case, and here a max sentence length of 512. These components are then, as I said, assembled into a Spark pipeline. Let me close this, and we can then use that pipeline and fit it on some sample text. So here you can see the text is, my name is John Parker, and I live in New York. We put this we create a Spark data frame using this text. The pipeline that you saw earlier is then fit to this text, which creates a pipeline model, which we can then use to transform this text and obtain some results. So here you can see John Parker is recognized as a person, and New York is a location. And so it's very basic, as you can see. We had a 3-step pipeline. We assembled it and then fit it to a sample text and transformed to get these results. These results are after a tiny bit of manipulation, but yeah, very simple. So we can move on to BERT for sequence classification now. As you can see, it looks almost identical. So again, document assembler, tokenizer, tokenizes your text. And in here, the only difference is we're using BERT for sequence classification. Here we're using a pre-trained model, which was trained to identify whether movie reviews were positive or negative. So as you can see, IMDb here. And again, so it takes in token and document column and predicts whether the review was positive or negative. Again, case sensitive, true, and max sentence length of 512. The pipeline is assembled using these 3 components. So very, very, very similar, almost identical to BERT for token classification. And in this case, we've got 2 sample texts that we want to try out. So here, the first one is, I really like that movie. And the second sentence is, the last movie I watched was awful. We create a Spark data frame with these 2 sample texts. Again, fit the pipeline, which creates a pipeline model, which can then transform the data frame and come up with these predictions. So I really like that movie. Of course, that's positive review. And the last movie I watched was awful is a negative review. So that's how you use them in Spark NLP. I'll go over some quick implementations in Colab on how to do this, but this is just an intro for now. So next, I just wanted to also mention that the pre-trained models I was showing, as you saw in Spark NLP in total, there are over 6,000 pre-trained models, and including those BERT for sequence classification and BERT for token classification. And those can all be found on the NLP Model Hub, which if you use this link, you can access it. I can also leave a link for those interested. So within the Models Hub, you're able to search for all these different models. And here I've left some examples of models that are available in the Models Hub. These are just screenshots of model cards, which you can then click on to obtain more detailed explanations of what the models do and what what they should be used for, and that kind of stuff, how to use them. All that can be found within the model card. And so this is the one we were just using, Cornell 2003, and this is one from the licensed library. So Johnson Labs has a Spark NLP for healthcare library, which is specific to healthcare and is licensed and contains many pre-trained models for different various NLP tasks that are healthcare specific. So in our Models Hub, again, you'll be able to find basically all models that cover your use case. but if ever you need to train custom transformers, such as in our, in today's um, case, we're talking about BERT for token classification and BERT for sequence classification. Those can be trained, they can be simply either PyTorch TensorFlow along with the Hugging Face Transformers library, or they can also be trained just using the Hugging Face Transformers trainer class. And once they are trained, you can head over to this discussion thread here. This is in our open source repo. And within this thread, you'll find tons of notebooks to import these different transformer models into Spark NLP. And the reason, so you can look at this thread. I can also send a link later to find this. The reason you would want to do this is, again, to be able to scale your models effortlessly, since you'd be now running on top of Spark NLP. And so I think that we can jump into the practical implementations. So over here, I'm going to be going over two notebooks that are from the Spark NLP workshop repository within the John Soul Labs organization. Within that repository, there's a tutorial folder where we have tons of notebooks to show users how to make use of all the different functionalities of the library. And within the public component, which is the open source component, we've got these two notebooks that are of interest today. So transformers for token classification, which includes BERT, of course, for token classification. And we've got BERT for sequence classification as well. So two separate notebooks. I'll include links to these. Yeah, so for now we can run through them. So let me just exit out of this and open up Colab. All right, so just to show you the repository. So again, here we're within the Spark NLP workshop repository. We've got this certification trainings, so tutorial certification trainings folder, and we're within the public or open source component. So in here, you'll see tons of notebooks that are used to do different tasks within Spark NLP. So from the basics to training NER models, but the ones of interest today are related to transformers. So here I've opened up the transformers for excuse me, for sequence classification in Spark NLP and token classification. So I've opened them up. These are entirely runnable in Colab. So here, so this notebook lists some sample models that you can use for token classification. So as you can see, it's very easy to install a library. Just pip install Spark NLP. And when you scroll down here, so this should look familiar. When we went over our example, we have our core components, which are the document assembler, the tokenizer, and the pre-trained token classifier. There's an additional component here, which is the NER converter. Essentially, this takes the output from the token classifier, which is in IOB format. As you saw, there were like the B. It was like John Parker, so B person, I person. So that's IOB format, and it converts it into a chunk format. So that John Parker just gets assigned a chunk called person. And so here we're assembling the pipeline. We then create a data frame with a similar sentence. So my name is John Parker. I live in New York, and I'm a member of the New York Roadrunners. So we're fitting the pipeline to the sample text. So let me just run this. So we're fitting the pipeline to the sample text and transforming to try and get some results. And as you can see here, the stages, we can print out the stages of the model. Again, this corresponds to what we had earlier. So document assembler, tokenizer, BERT-for-token classifier, and an NER converter. So once that's done, we can then look at the different classes that are predicted by this model. So as you can see, as I mentioned, Coronel 2003 has a location, organization, there's a miscellaneous tag as well, and person, which I didn't mention yet. So yeah, so those are the different classes which you can print. You could get, so here, let me just run this. And you can get the classes, you can get the columns from the resulting data frame. You can print the schema if it's of interest. And here, just by manipulating the results a bit in PySpark, we can get this neat data frame, which displays each, so it's basically each token. So one line per token along with an NER label. And so, as I said, this is an IOB format. And so John Parker is a person, New York location, New York Roadrunners organization. And if you want to look at the chunks, so instead of this IOB format, you can get chunks here just by running this. And so John Parker, again, a person, New York location, etc. So that's for token classification. It's pretty straightforward. Once again, I'll leave a link to be able to access these notebooks. You can run them directly in Colab. Over here, I have the BERT for sequence classification. Excuse me. So again, very similar layout. So we've got some sample pre-trained models that you can use for different tasks. And I'm just going to scroll down. So again, you just pip install Spark NLP and start your Spark session. And over here, we have the for sequence classifier. So as I said, very similar. You're using a document assembler first, tokenizing your text, running it through this IMDb, so sequence classifier, which classifies movie reviews, and just putting this into a pipeline. The sample texts we're using are the exact same ones I was showing in my example. So these two different texts, we're creating a data frame, fitting the pipeline, using this data frame, and creating a pipeline model, which we then use to transform this data frame and get predictions. And so here, in terms of, you can, again, the exact same thing, you can print the stages, you can get the classes from the the sequence classifier. You can get the resulting columns, print the schema, and over here, you're able to print the just the predictions along with the sample text that was inputted in. So again, I really like that movie. It's a positive prediction. And the last movie I watched was awful, which is a negative movie review. So yeah, so this is basically it. It's quite straightforward to use both the BERT for token classification and BERT for sequence classification within Spark NLP. Yeah, I think that will be it for me today. Thanks for watching.